All right, let's get right into it. We all know that Docker containers are meant to be these neat, isolated little boxes. But that very isolation brings up a huge question. How do these boxes actually talk to each other, or to the machine they're running on, or even the outside world? Well, that's exactly what we're going to unpack right now, the world of Docker networking.
And this really is the core of it, right? If a container is its own self-contained universe, how does it ever send or receive a message? The answer is all about Docker's powerful and, yes, sometimes kind of confusing networking drivers. We're going to break them all down one by one.
So let's start with the one you've probably been using this whole time without even realizing it, the bridge network. Now, to really get what Docker is doing, we first got to understand what a bridge is in, the real physical world.
I want you to imagine a big, busy office with like 30 computers all on one giant network, all trying to shout at the same time. It's total chaos. Data packets get dropped, that's what we call collisions. A physical bridge is the smart device that splits that one chaotic network into two smaller, quieter ones. It's basically a smart traffic cop, directing data only where it needs to go.
Docker does the exact same thing, just virtually. When you install Docker, it creates this default bridge network for you, usually on a private IP range like 172.17.0.0. Then, every single container you launch gets plugged into this bridge and handed its own private IP address. And boom, just like that, they can talk to each other right out of the box.
So great, everything just works. Problem solved, right? Well, not quite. The default bridge network is super convenient for sure, but it has one huge drawback that makes it a pretty bad idea for most production setups, or even for complex development. And this really highlights why you need to take control of your networks.
Okay, so here's the catch with the default bridge. Your containers have to know each other's exact IP address to talk. But the real magic happens when you create your own user-defined bridge network. When you do that, you get automatic DNS resolution. This means your web app container can find your database container just by using the name database. You don't have to care about its IP address, which could change anyway. And that, my friends, is an absolute game changer.
And look, this isn't some niche, expert-level trick. This is the standard. As Christian Lempa says, the user-defined bridge is what you'll use for 90% of everything you do. So the big takeaway here? Seriously, stop using the default bridge. Creating your own is probably the biggest, easiest win you can get in your Docker workflow.
All right, so we've got the bridge network, which is our workhorse. Now let's look at the two polar opposites on the isolation spectrum, the host network and the none network.
The host network driver basically just rips down the wall between your container and your machine. The container doesn't get its own IP address, it literally just hijacks the host's entire network setup. So if something inside the container is running on port 8080, it's now running on your machine's port 8080. The upside? It's crazy fast. There's no translation layer, no NAT, slowing things down. But, and this is a big but, that speed comes at a price. What happens when you try to launch a second container that also wants to use port 8080? Bam! You get this dreaded error. Because the host port is already taken, the second container just fails. So trying to scale up with the host network? Yeah, good luck with that. And then we swing to the complete opposite end of the spectrum with the none network. This puts your container in a total digital prison. It has zero connection to the outside world. No talking to other containers, no talking to the host, definitely no internet. Nothing. It's completely sandboxed. So you're probably thinking, why would I ever use these? Well, host is all about raw, unfiltered speed. Think high-traffic proxies where every nanosecond counts. And none? That's for your super-secret, lockdown-level security jobs, maybe a batch process that crunches sensitive data and absolutely should not be on any network. All right, so far we've been living inside Docker's virtual world. But what happens when your container needs to step out into the real world, onto your actual physical network? Well, that's where these two show up, MAC-VLAN and IPVLAN. Think about it like this. Up until now, our containers have been hiding behind the host machine with these private IPs. We've had to do all this port mapping to talk to them. But what if you need that container to be a true citizen on your network, to have its own IP address on your home or office LAN, just like your laptop or a physical server? The perfect real-world example for this, running something like Pi-hole in a container. See, Pi-hole is a DNS server, and DNS has to run on port 53. It's a non-negotiable standard. But your host machine might already be using port 53. MAC-VLAN is the hero here. It just gives the Pi-hole container its very own IP, completely avoiding that port conflict.
Now, setting this up might sound a little scary, but it really just boils down to 3 steps. First, you got to find the physical network card on your host, like ETH0. Then, you create a new Mac VLAN network and basically tell it to use that physical card. And finally, you just launch your container onto that network, giving it its own shiny new IP address from your LAN. You know, you'll probably see IPVAN pop up right next to MacVLAN, and you might wonder what the difference is. Honestly, it's super simple. MacVLAN gives every container its own unique MAC address, so it looks like a totally separate physical device to your router. IPVLAN, on the other hand, makes all the containers share the host's MAC address. Now, why would you want that? Well, some really strict corporate networks might freak out if they see a bunch of different MAC addresses coming from one physical port, so in that rare case, IPVLAN is your friend. Okay, everything we've talked about has been on a single computer, a single Docker host. But in the real world, in production, you're running containers across a whole bunch of machines. So how do they talk to each other? The native Docker answer to that puzzle is the overlay network.
Think of an overlay network as this: magical, invisible layer that stretches across all your different physical servers. It lets a container on one machine chat with a container on a totally different machine, like they're sitting right next to each other. It's encrypted, it's secure, and it's seamless.
This is really the secret sauce behind Docker's own orchestrator, Docker Swarm. But let's be real. In today's world, for the big, heavy-duty production stuff, this kind of complex networking is usually handled by the big kahuna, Kubernetes, which brings its own even more advanced networking game to the table.
Whoa, okay, we have covered a ton of ground here, from the simplest bridge to these complicated Mac VLANs. So, with all these options, how in the world do you pick the right one? Let's boil it all down to a super simple guide.
All right, here it is, your cheat sheet. For like 90% of what you're going to do, just start with a user-defined bridge. You get isolation, you get that easy DNS by name. It's the best practice for a reason. Need absolute maximum speed and you don't care about isolation? Host is your guy. Need your container to be a real player on your home network with its own IP, like that Pi-hole? That's a job for MacLAN. And finally, if you need to lock a container down in a secure box with no internet, none is what you want.
And that really brings us to the final question, the one I want you to walk away with. Now that you know all this, I want you to go look at your own projects, your own Docker Compose files. Are you still just letting Docker use that default bridge? Could that annoying port conflict you've been fighting for weeks be solved with a simple MacFlan? The big question is your application on the right network? Something to chew on. Thanks for tuning in.